All right. So, what do you guys want to do? I'm looking at per day.
Find the confidence interval.
Before I do the confidence interval, I got to make sure I'm allowed to do the confidence interval. But when I see construct and interpret the confidence interval, I'm going to draw my boxes because I know I'm going to have to use them. Okay? And what goes in the first box? Procedure. So what procedure should we do here?
One sample Z interval.
A one sample Z interval for P.
Is it two calculators because you just put int dot? Like, would that be bad?
If you said one prop Z int instead of a one sample Z interval for, int is not two calculators speak. One prop Z int versus...
Just like one sample Z int.
Yeah, that would be fine.
Toe in the line.
Okay? Where P equals the true proportion. You guys, rather than write out that whole thing, are you cool if I call this soda stealers? It's a nice little alliteration. And yes, in Miss Meister's opinion, asking for a water cup and then getting soda is stealing. Okay. Everybody good so far? Does this feel reasonably close to what you're supposed to be already know how to do? All right. So then let's do the next part, which is
Random.
checking our conditions. So we're going to do random. I think we were told it was we were given random sample.
Yeah, random sample of 80 customers.
Okay. Normal.
We need to find P hat.
We got to find P hat. I got it. How do I do that?
23 of 80 customers.
23 out of 80, which is like a little bit more than 25%.
28.7.
0.2875. So to check that normal condition, I'm going to do 80 times that 0.2875. And then 80 times 0.7125. Just doing 1 minus that 0.2875. And P and 1 minus P. I'm hoping that's starting to feel really, really innate inside your guys' heads. That some version of NP and 1 minus P. And I get 23 and 57, I think.
Yes.
At least we should. It should, whenever you're multiplying by just normal P hat, it should just be your number of successes and your number of failures. Okay? Independent?
Is less than the, like, all customers who ask for a water cup.
80,
Is less than
10% of water cup customers.
Yeah, it is.
All right, we good?
He's not gonna.
What's next?
The confidence interval.
Actually getting the interval. You guys, you're always allowed to use calculator shortcuts now. So let's get to that interval really, really quickly. We hit. Tell me what to hit. Stat. Arrow over to tests. Do you get...
A.
Let's look for something that would work for proportion and z-interval. Do not pick number 7. You want to do the one that's the z-interval for proportion. I hit enter. If you just do z-interval, it gives you the z-interval for a proportion, or for a mean instead of the z-interval for a proportion. Basic premise, if you pick one and it's asking you for something you don't have, go back and say, there might be a better one for me to pick. You guys, is everybody good in terms of the 23, the 80, and the 0.95? You hit calculate. You guys, I found the interval to be 0.188 to 0.387. Conclusion should be pretty straightforward. We are 95% confident that the interval from 0.188 to 0.387 contains the true proportion of soda stealers.
On the AP exam, are we ever going to be expected to find the interval with that formula?
So on the AP test, the way you might be asked about that formula is finding sample size. So you still need to be familiar with your margin of error is your critical value times your standard error. Or a lot of times they'll say, which of the following will give you the correct interval? And they give you the formula filled in. So you should be familiar with the formula, but you won't need to use it by hand. More importantly, you won't need to type it into your calculator and risk making a tiny mistake. Okay? All right, let's look at part B of this. The manager estimates that each customer who does this costs the restaurant 25 cents, and in June, 3,000 customers did this, okay? So if I wanted to come up with an estimate for how much money the company lost, okay? If the lowest proportion that did this is 0.188, okay? We could say, first of all, how many customers is that? So I would do that 0.188 times 3,000. Does that make sense? And if each one of those customers costs 25 cents, I multiply that by 0.25, and it's going to tell me that my new interval and you guys, I'm not that smart. So that's $141 that it could have cost this franchise. That's the lowest this thing would cost. Okay. What's the highest? We take do the same thing with the 0.387. First, how many customers, and then multiply by the cost per customer. So, believe it or not, this question is not really a statistics question. It's a problem-solving mathy question. 290.25. So in the month of June, these soda stealers could have cost the company somewhere between $140 and $290, give or take, because I have that a little different. Does this make sense? Sweet.